Hey you, yeah you, is the water heater in your RV not working? I thought so. Do you want to figure out how to fix it? I also thought so. If you got a multimeter, then today I'm going to walk you through step by step how to test all of the parts in your water heater to figure out what your problem is. My name's Emily Kistler. I'm a certified RV repair tech based here in Las Vegas, and this is RV Repair Woman. Let's go. I'm going to be talking today specifically about Atwood / Dometic water heaters. Dometic bought out Atwood, so their water heaters are wired exactly the same. If you have a Suburban water heater, the machine itself is nearly identical, just some of the wire coloring might be different, and sometimes there's an extra switch. So know that you can still follow this process. The colors of the wires might just be a little different. And if your water heater is gas and electric, today I'm only talking about the gas side, but know that if you do have an electric water heater, the electric side of things is entirely separate. So none of the wiring that I am talking about interacts with the electric side of the water heater at all. That's all AC power and relays, and it doesn't even interact with the circuit board. So if your water heater is gas and electric and it's not working on gas, this process today will still work for you. Onto your multimeter. I'm going to walk you through real quick the two tests that you're going to need on your multimeter in order to test your water heater today. I'm going to show you how to set them up on both my fancy meter, quote unquote fancy meter, and this really simple meter, just so you can see it on both. So the first test that you're going to want is DC volts. If you remember from physics class in high school, there's two types of electricity, AC and DC. AC electricity is what controls your water heater if it's on electric and has an electric side. If you are talking about a gas-only water heater, which is what we're talking about today, all the power is DC. It's lower voltage, primarily 12 volts, coming from your batteries. So on this meter, to get to testing DC volts, I just click it over to that. And then on my meter, it's set default to AC power. So I just hit this select button and that squiggly line turns into a straight line. And now I'm ready to test for DC volts. If you have a meter that is not self-ranging, it basically means this meter, I can go test millivolts, I think all the way up to kilovolts, and I don't have to tell it whether I'm testing for something small or for something large. It can automatically detect whether I'm looking at a little amount of voltage or a big amount of voltage and range it itself. If you have a simpler meter like this, that's why it looks like it has so many more options, is because on the DC volts side of things, you have to tell it roughly what range of voltage you're looking for. We are looking for roughly 12 volts, so we are going to set it to the 20 because that is the closest number to 12. Cools. So this meter and this meter are both ready to test for DC volts. Let me put my little probies in. When you are testing voltage, you are going to be having your two probes. If you look at your water heater, you're going to see a screw that a bunch of green wires go to, and it's screwed into the side of the water heater itself. When you are testing for DC volts, you're going to take one probe and touch it to the metal part of that screw, and then you can take your other probe and poke it around on other parts of the water heater. And that's the case whether you're using a fancy meter or a simple meter like this. When you're looking for DC volts, you're really just looking to see, did the voltage make it to this point in the circuit? If the voltage didn't make it there, we're then going to backtrack one step and figure out why. What happened in between the last place we checked and this place we checked, and the thing in the middle is probably going to be the part we're going to replace. Relatively simple. The only other test you're going to need today on your meter is the continuity test. So on mine, it is over here. It's the one that looks like a little audio symbol. On the simpler meter like this, it's down here near the bottom and also has a little auto symbol. The reason it has that is because you can test your meter by touching your two probes together, and it's going to make an annoying beeping noise. That test is the continuity test. So if voltage is telling us whether or not the electricity made it to that part of the circuit, continuity tells us whether or not the electricity could make it through that part of the circuit. stick with me. Imagine you have a chasm and you're standing on one side, and we want to know whether or not there is a bridge across the chasm so I can get to the other side. We would test that with continuity. So we would take our probes, put them on either side of the chasm, or in this case, an element in the circuit, and if it beeps, that tells us that electricity can make it through the circuit. If it doesn't beep, it tells us that at least this level of electricity cannot make it through that part of the circuit. Really pretty simple. So unlike when we're testing for volts DC, where we're going to be putting one probe on a screw and poking around with the other one, when we're testing for continuity, we're going to take our probes and put them on either side of an element in the circuit. If you're a little overwhelmed, don't worry. I'm going to walk you through step by step where your probes are going to go for each step of this. You got this. It's really not that difficult. You can do this. On to testing your water heater. If you see me looking down, it's because I am checking my wiring diagram that I got from school. Okay, so your first step is going to be to turn your water heater on. I know some of you are rolling your eyes. Stick with me. I've actually gotten calls where I show up and people say their water heater isn't working, and it's just because they didn't know how to turn it on. So don't let that be you. Here's what you need to know. Some, and they're usually suburban water heaters, have an extra switch on the water heater itself. And if you have that switch, it needs to be in the on position. It can be a little hidden behind this gas pipe, so just take a look for it. Again, they're usually only on suburban water heaters, and we're mostly talking about Dometic today, but that's just something to know. Either way, whether you have a switch on the water heater or not, there is going to be another switch inside of the rig to turn the water heater on. If you do have two switches, they both need to be on in order for the water heater to work. This is an and situation, not an or situation. We're mostly talking about Atwood Dometic today, so it only will have the one switch and it'll be somewhere inside of your rig. So go hunt it down and turn it on. There's a chance that that'll solve your problem. Step 2, this is where we get to pull out the multimeter. We're actually gonna go to the water heater, open it up, and you're gonna see a bunch of wires, some terminals in the middle, a circuit board probably in the corner. Don't get overwhelmed. We're gonna go through this all step by step. So the first step that the electricity goes on in its path is down a brown wire and into something called an T-stat. Editing Emily here, filming Emily accidentally called the T-stat the ECO through this entire section of the video. And I did my best to edit around it. It's very obvious, and we're all just gonna bear with it. It's okay. I'll explain later in the video what the ECO is. Essentially, T-stats and ECOs are almost exactly the same thing, and they sit next to each other on the water heater, which is why I got the names reversed. I apologize. We got this. We're just gonna pretend it never happened together. I'll talk in just a minute about what the T-stat is, what it does, and how to test it. But the first thing we're going to do is see if the power is even making it to the T-stat. This is where we're going to test for DC volts. We're going to take one probe, touch it to that screw, and we're going to take the other probe and touch it to the terminal coming out of the T-stat. You may need to pull back on the connector that is on that terminal in order to expose enough metal for you to get your probe in. If and when you do this, take a finger and put it in right on the T-stat in between the two probes. It's not going to shock you. You're good. And support the T-stat as you're pulling back on that terminal with some needle nose pliers. There is a spring mechanism behind the ECO, and if we just start tugging on the terminals, that spring can pull back, smack back into the tank, and then hurt itself and cause more problems than we are fixing. So let's not do that. Support it with a finger. Pull back on the terminal carefully with needle nose. We're doing great. So we've pulled back on the terminal and we are testing for DC voltage. You should see a reading in between 11.5 and 14 volts. Ideally something in the realm of 12.5. That's the goal. If you're plugged in and your converter's on, you're gonna see something closer to 13.5. If you're not plugged into shore power, it's gonna be closer to 12.5. If you're seeing 0 volts, then the problem is not with your water heater at all, and the problem is upstream. So go check your fuse panel, make sure all your fuses are good. Check out my video here on how to test your fuse panel. Go make sure that your batteries are good, that they're charged up enough, that they actually have enough oomph to turn on the water heater. If it's not your fuse panel or your batteries, then you have a bad connection probably somewhere in between your fuse panel and the water heater, because your water heater is not getting enough voltage to turn on. If you are seeing a number above 14, I've never seen that. So there's a chance, and I bet I could show you on this meter. There we go. If you're seeing a number above 14, like in the hundreds or the 70s, there's a good chance, if you look very closely, that there's a tiny M before the V in your voltage, and you're actually reading millivolts, not volts. Any reading of a millivolt in this test is so small we don't care about it. So again, 11.5 to 14 volts. I've never seen anything above 14. I guess maybe if you had like a very fancy lithium charger on, you might get up to like 14.5. I'm gonna call it 12 volts. Just know you want a number close to 12.5 throughout this test. For the most part, you're gonna see either something in the realm of 12.5 or 0, and we're gonna walk through the whole test. Capiche? So I'm assuming we've seen 12 volts on this brown wire. Now the voltage needs to make it through the ECO. What is the ECO, you ask? Well, the ECO is a temperature sensor inside of your water tank that is detecting whether or not the water is too hot. And if it is, it shuts the whole system down. It does not let any voltage through. And that's what you want. You don't want your water heater to continuously always be on. You want it turning off when the water gets to temperature. That's the ECO doing its job. The ECO is just a switch. If the water's too hot, then the switch is open and doesn't let electricity through. If the water is not hot enough, then the switch is closed and it lets electricity through. Unfortunately, sometimes these things can fail open or they break. And so even though the water heater hasn't been on in days, and the water is definitely cold, it doesn't let electricity through. So here's how you're gonna test that. You're gonna look for 12 volts on the other side of the ECO. T-stat. So the side that did not have that brown wire coming down from the wall. Again, put one probe on that screw, one probe on the other side of the ECO. You should see something in the realm of 12 volts. If you do not see 12 volts, then we're going to double check our work by taking both terminals off of the ECO, so it's bare, naked, not connected to the circuit at all. Then we're going to switch our meter over to continuity. Remember, that's the one that makes a sound. And we're gonna touch one probe to each side of the T-stat. If we hear a beep, then the T-stat is fine, and we need to go double check our work again. If we don't hear a beep coming from the meter, that means the ECO is bad, and it's time to switch that bad boy out. That's your problem. We're doing great. If you just peel back the foam, you should see it there. Remove it, replace it with a new one, and you should be good to go. Assuming that we have seen 12 volts on both sides of the ECO, the next step in the electricity's path is to go through something called a thermal cutoff. Thermal cutoff is, again, just another temperature sensor. You're gonna see a lot of those today. Again, one probe on the screw, one probe on that bare side of the terminal, and you should see, say it with me, 12 volts. If you do not see 12 volts, then we can double check our work by completely disconnecting the thermal cutoff from the circuit entirely and setting our meter to continuity, putting one probe on either side of the thermal cutoff. If we hear a noise, then the thermal cutoff is good and we need to go double check our work. If we do not hear a noise, then the thermal cutoff is bad. Replace that bad boy and you should be good to go. Assuming that we are seeing 12 volts all the way through the thermal cutoff, then we can head our way on over to the circuit board. The next place that we should see electricity is on the brown wire going into the circuit board. So again, one probe on that screw, one probe on the brown wire, and we should see 12 volts. You're gonna see real quickly, you're gonna do the same test over and over. If you do not see 12 volts on that brown wire, it would be really weird. The only thing connecting that thermal cutoff to the circuit board is that brown wire. So if you somehow have 12 volts on the thermal cutoff, but not on the circuit board, there's something wrong with that wire. I doubt that's gonna happen for you. So, assuming that we saw 12 volts going through the ECO, through the thermal cutoff, and into the circuit board on the brown wire, then the next place that we are going to look for 12 volts is going out on the blue wire. So again, one probe on the screw, one probe on the blue wire, and we should see 12 volts. That blue wire is sending out electricity to the indicator light inside of your rig to tell you that your water heater is on. If you have 12 volts on the brown wire, but not on the blue wire, then it's most likely that your circuit board is bad. Look over your circuit board and see if it has a fuse that you can take off and replace. Double check that fuse for me if it exists. Just pull it out with some needle nose pliers, set your meter to continuity, put one probe on either side of the fuse. If you hear a beep, then the fuse is good and there's something wrong with the circuit board itself. If you do not hear a beep, then the fuse is bad. Take it to your local AutoZone, O'Reilly's, auto store of your choice, slam it on the front desk, and someone should be able to get you that fuse. Pop a new one in and hopefully that'll solve your problem. Assuming that we are seeing 12 volts on the brown wire and 12 volts on the blue wire, we're cooking, we're doing great. We should be hearing a ticking noise coming from the igniter. If we are not, then there's a chance our igniter is bad. So there's two things we want to test for. If you are not hearing any ticking at all, then what I want you to do is very, very carefully and with some needle nose pliers that are insulated and making sure that our hands are not touching any metal part of the needle nose, you can very carefully disconnect the terminal from the igniter on the circuit board and then hold that terminal close to the metal part of the igniter and you should see a spark arcing across. If you do not, then the igniter on your circuit board is most likely bad. Again, double check and make sure that that fuse is good on your circuit board if you have one. If you do not, then your circuit board is most likely bad. If your igniter on the circuit board will arc to the terminal while you hold it close, but when you reconnect it, you do not see a small arc on the igniter that is inside of the tube on your water heater, then there's a chance that that igniter down there is bad. Go ahead and disconnect it and give it a little clean off with an emery cloth, a little bit of sandpaper. Just make sure there isn't some ash or something that's preventing that arc from happening. And make sure that the two probes are close enough to each other that electricity could arc across. I'll put up here the distance they're supposed to be from each other. I don't remember off the top of my head. I haven't had this be a problem before. If the distance is off, it's most likely because someone has mucked around with it that shouldn't have. It happens, or that you bent them a little while you were trying to clean them. So I have yet to have the igniter be the problem on a water heater, but hey, it does happen. So assuming that we've got 12 volts on brown, 12 volts on blue, and we are hearing a ticking noise coming from the igniter, then the next stop on our electricity journey is to look for 12 volts on red on the circuit board. So again, say it with me, one probe on the screw, one probe on the red wire. Wow, my voice is getting low. Do I have some water? Keep a note that during startup, you are only going to see 12 volts on red while you hear the igniter ticking. This is because the 12 volts going out on red is meant to open up the gas valves to let propane through, and the system is only going to open those gas valves when it knows that there is an igniter there to ignite the propane, so we are not just dumping propane everywhere and not burning it off. We are not turning this water heater into a bomb. Woo! So we're testing for 12 volts. We should see 12 volts on red while the igniter is ticking. If we don't see 12 volts on red, then it's most likely the circuit board is the problem. Again, look to see if there's a fuse, test it if you need to. If the fuse is good, then it's most likely that the circuit board is your problem. I know it sounds like the circuit board could be your problem quite a bit. It's just because there's a lot of wires going to it. It is not always the circuit board. That is not always the thing you need to replace. It just has the most wires going to it, so it has the most points of contact to test, if that makes any sense. So now, assuming that we have 12 volts on brown, 12 volts on blue, we're hearing a ticking noise coming out of the igniter, and we have 12 volts on red, then the next step is to test the T-stat. Oh my God, I said ECO in the beginning. Fuck me. We're back. I'm just gonna make future Emily fix it in post, because I cannot be bothered. Everything's fine and cool and fine. Nothing is wrong. I'm feeling great. Where were we? Assuming you are seeing 12 volts on brown, 12 volts on blue, 12 volts on red, then the next step in the electricity's journey is to the ECO. The ECO, and why I confused it earlier, is almost identical to the T-stat. It has a nearly identical job to the T-stat. It is in fact just a last quadruple millionth check that the water heater is indeed not too hot before we allow propane to be dumped into the system. It just has a higher heat tolerance than the T-stat does, so we can test it exactly the same way as we tested the T-stat. So again, we're going to pull out a little bit on the terminal, on the side that is coming in from the circuit board. Again, when we go to pull out on that terminal, use a finger to support that little ECO. Pull out on that terminal. There's a spring behind it too. Don't allow that spring to pull back and smack against the side of the tank. You will be sad. Don't be sad like me. Use your finger. If you see 12 volts going in on the side that comes from the circuit board, then we're going to test for 12 volts on the other side. Again, one probe on that screw, one probe on the other side of the ECO. Oh my God, I'm going delirious here. You should be doing fine. I've been sitting on this floor too long. All right, we're pumping up. We're getting the energy back. We are not sad about saying the wrong thing earlier. We can make mistakes and still be a functional human. Let's go. If you see 12 volts on the side coming in from the circuit board and don't see 12 volts on the other side of the ECO, then it is most likely the ECO that is the problem. We can double check this exactly the same way that we double checked the T-stat, and that is by removing both terminals off of the ECO so it is naked and separate from the circuit entirely, and then setting our meter to continuity, putting one probe on each side of the ECO. If we hear a beep, then the ECO is good and we need to double check our work. If we do not hear a beep, then the ECO is bad. Pull back that foam, you should see that sucker. Go ahead and replace him and your water heater should be good to go. Woo! We're getting to the end here. If you somehow have power on all of the places on the circuit board, we're hearing a ticking noise coming out of the igniter and we get power making it all the way through the ECO. Then the last and final stop on this beautiful journey is to go into the gas valves. There is a way to test if your gas valves are good. It is a bit more involved than I want to get into on this video. Just know, if power's made it all the way through the ECO, you can put a probe here, find a little bit of metal on that terminal, stick it in, and see if you see 12 volts, just to make sure like somehow the wire in between the ECO and your solenoid isn't bad. But for the most part here, we're gonna use our ears and our nose. So if power makes it all the way to the solenoids, you should hear a click come out of the solenoid. Keep in mind that that is a different noise than the tick we're going to hear coming out of the igniter. The full sound story, if you will, is going to be click, tick, 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 whoom. So the click is the solenoids opening up to allow gas to go through. The tick, 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 tick is the igniter trying to ignite that propane. And the whoom is hopefully ignited propane and some flame and you get hot water. If you have power making it all the way to the solenoid and you do not hear a click, then it is most likely that your solenoid is bad and you can look at replacing that. If you get power all the way to the solenoid and you do hear a click, but you don't smell propane, then it is most likely that you have a propane problem and not an electrical problem. Go make sure that your propane is actually on. go try another propane appliance like your furnace or your stove, just to make sure that propane is definitely making it out of the propane tanks. If your propane is definitely on and definitely good, then it might be time to call a tech. We're getting into some finicky crap, and they can test to make sure that like your solenoid isn't somehow clicking but not actually opening, which can happen. It just is rare. But you at least know that you tested all the other stuff. And if they come in and tell you that it is a bad circuit board, you can tell them to shove it, because you know it's fine. You know it's good. You tested it. Everything's fine and good and fine. Nothing is wrong. You're feeling great. I hope someone out there knows this reference. But in the end, that's it. That is all of the electrical parts to your water heater. It is just electricity going through a bunch of checks to make sure that your water heater hasn't gotten too hot and making sure it doesn't turn into a bomb. That's all you gotta do. Just follow the yellow brick road, follow the path of the electricity, see where it stops moving, go back one step and check for continuity. Make sure that power could make it through the part that it just left. If it couldn't, then that part's your problem. If you found this video helpful, please let me know down in the comments if you would like a video walking you through how to test the electric side of your water heater, or maybe a suburban water heater. Let your girl know and hit subscribe. I am an RV tech out here telling you all the RV tips and tricks that most techs don't want you to know. I also have a maintenance guide in the description. The #1 way to save money on RV repairs so you don't have to call a tech like me is by doing some RV maintenance. And I walk you through with step-by-step instructions how to maintain everything from your water tanks to your air conditioner to your water heater. This has been RV Repair Woman. You got this.